everybody, welcome to the channel. Alright, we got the fusion screen. This is a rather simple part. This is the adapter plate or mount plate for the NEMA 17 stepper motor. The way it's situated in the ATC, adjusting the belt tension would be impossible because of the fork disc and everything in the way. So this plate is to mount from the top side, so all I have to do is pull the drive assembly cover off rather than having to deal with removing everything from the bottom of the ATC to set the belt tension. So this starts out as a piece of 1/4 inch stock. It measured out at 257. And we're doing the part lengthwise to the machine. As I normally do, I center with about 0.010 on the top, so that way I got plenty to grab on the vise and just a small amount to surface on the actual first portion of it. So like I said, we have a facing operation, and then we have an adaptive, and that goes around and trims all that, and that's done with a 3/8 end mill. And then a contour with a 3/8 end mill bore to open the center section up, and then a drill. We drill in here, and then we have the another drill. The first one was the center drill, and then this one is a chip break to go all the way through. And then we do a slotting operation. As you can see, this is with an 1/8 inch end mill, 3 flute, and then follow it with a contour. And on all of these, the slot, the contour, I'm going past the bottom of the model by 0.010 of an inch, so I make sure I have good clearance. And then we follow up with a chamfer all the way around. And then we move to the underside of the part. And then we do a face, and this is followed up with a finishing pass on there. This part is really thin. It's only 1/8 of an inch thick once it's done. When I machined it, I should have done 2 finishing passes, really light finishing passes, because of this thinner areas here, and then clamped in the vise you get a little bit of chatter, so you'll want to make sure you go really thin on your finishing pass. And then we follow this up with a chamfer rotation on here. Also, this one has countersunk screws, so when you look at it, I don't have a countersunk bit for my mill yet, so this will be a drill press operation once this is all done. They're simple, so let's head out the shop and we'll see what you got. Alright, we're out in the shop again, and today we're making the NEMA 17 motor plate on the ATC drive plate that the motor actually mounts to. I designed it where you could adjust the loosen the screws to be able to adjust the belt tension from the top, because the belt and stuff is inside of the actual enclosure of the ATC. So we need to be able to access it by removing just the enclosure that covers the motor and stuff, and be able to adjust the belt tension. So this is a really small plate. We're just going to machine it up and then show you our what it looks like as we're going through in stages. So stand by. We're got the plate already loaded. It's already zeroed out and it's ready to go. All right, here we are at the part. It came out really nice. When I had the last one of the last episodes, my surfacing bit, the actual tool bits needed to be changed on it, the inserts. So I changed it, and so my surfacing looks so much cleaner now. So anyways, we got this side done. We got to flip it over, reprobe it in, and then do the other side. So we'll come back when it's done. Alright, we are all done with this part. This is just a motor plate, as I noted. It's got chamfered holes so that the screws come through into the motor itself up here, and then allow it for it to slide via the slots on here and there. And then this corner is beveled off to allow clearance for the wire coming from the proximity sensor from underneath. So all in all, this is all done. The quality looks so much better with getting that changing those inserts on my bit. I did find that on these thinner parts I'm still struggling with it, but I dropped made a finishing pass to 10 thousandths when I was surfacing the excess off of this side, and I can see a little bit of scuffing, or I guess you'd call it chatter or something. So with these thinner parts I may have to consider a little bit thinner pass to try to compensate that, or multiple finishing passes to see if that fixes it. Anyways, we'll see what's next. Hello everybody, welcome back to Fusion 360. Today we are working on the linear rail plate. It's the linear rails bearings for this whole assembly to slide, and then back in here this mounts to the rigid mount that ties to the column, and then we have a pocket here for mounting position for the air cylinder mount. So we'll try to keep this short and sweet because there is a lot of different functions to cut this piece. It's actually very long. I had to make sure I had just the right amount of length. This total part's 13 inches in length, and you only have 14 inches of travel range in the 770. So I had to make sure that when I set this up in the mill, that I could probe, at least had enough room to probe, because I was never going to go out very far. I was going to be able to machine within the 14 inches, but it never, probing, you have to have a specific amount of travel in order just to probe. So, but we ended up making it, so we'll kind of go over it. First we start out with an adaptive, and that is just to clean up the two ends because I'm sticking with the factory finish on the metal. I did run a jitterbug, an orbital sander across the top and the bottom side to clean it up and give it a more uniform appearance. So again, an adaptive on the ends, and that's using a 3/8 end mill, and then we finish it off with a contour. So that just trues up the ends. I wasn't worried about the dimensions on the top and the bottom. And the surface finish is not that critical. If it's off 1 or 2 thousandths, it was not, the tolerance factors was more than adequate to deal with that. So anyways, then we do an adaptive, and that's to cut this pocket, and that pocket is for the depth of the air cylinder mount. So we do an adaptive in here, and that's done also with the 3/8 end mill, and then we follow it up with a contour, and then we bore out the hole. This hole is for the air fitting coming off the front side of the air cylinder, and then we come over here and do another adaptive. This pocket here is for the rotational, so it allows you to rotate this plate in this kind of direction, to rotate the plate this way, and it's slotted because of these back here, so it'll allow it to slide in and out towards the head of the machine. So we do an adaptive to clear that out. It's also with the 3/8 and then contour, and then we do a this is a zigzag to clear out the bolt head slots in here, and I had to shift it up to a smaller end mill, my 3/16 end mill, for this contour. I went ahead and did the contour with the 3/16 because I have to do a pocket, which is also another zigzag, to clear out the slot area in there, and then you can see that it finishes it up at the bottom. And then it's all drilling routines. So go through, drill all these M4 holes, and I went ahead and pre-drilled these as well. Actually, this is for the center drill, and then it's M4s, drills for the M6, and I've changed this, but I did it by accident. I machined my plate to an M5 but it's been changed in the future CAD. So for those of you that obtained my plans, this will be for an M4 screw, not an M5. I don't know what I was thinking when I did that. And then we have follow up with a chamfer routine for all of it, and then tap all of the M4 holes and then the M6 holes. I hand tapped the M5 simply because none of my compression tapping head doesn't, my M5 taps won't fit in it. So then we move on to the next function, and that is for a drilling. So I did a center drill on this end of the plate. This is for the spacer for the door lever, the lever that actuates the door opening when it transitions to the end to change a tool. So it was a drill for that. That was the center drill, then a drill, and then I chamfered it. I ended up hand tapping it because of the height of the plate. I don't have enough clearance with the compression tapping head, and I've yet to purchase any thread mills that would make quick, easy work of that. So anyways, we'll go back out in the shop and you can see this in working. Hey, welcome back out to the shop. Today we are making the linear rail plate. It's the long plate that the actual linear rails mount to. Then the rail bearing plate is what we did in the last episode, that mounts to the actual linear bearings themselves. So this time this is a really long part. The 770 only has 14 inches of x-axis travel, and luckily the plate is 13 inches in length. I have two vices, 4-inch vices, that I've mounted in tandem over here, so I got it mounted in place because this is mainly a drilling episode. I'm not worried about surfacing it. The tolerances are not that critical when it comes to mounting the linear rails, etc. Plus there's going to be a lot of play when you go to tighten the rails down, so I'm not too worried about the actual part for that. But this one's going to require some pocketing. I am going to machine the ends to square them up, and because I cut the material just a little bit longer just so I could true up the ends. There's going to be a little bit of pocketing, drilling, and tapping on here. The only tapping that I can't do is there's an M5 screw on here, and none of my taps fit in my compression tapping head, so I have to hand tap that by hand. So let me show you what we got. I ended up having to take the jaw plates off of my vices, so I had enough room to bolt this in. It's set in place. Like I said, all we have to do is a bunch of drilling and some pocketing routines in here. Nothing too major, but I am going to true these ends off. So we set my origin off of this corner, being only have it half an inch beyond the part on each side. That's why I couldn't do any surfacing. I didn't want to do a surface with a little tiny end mill anyways. So anyways, we'll get this set up and we'll get this going, and when we come back, we'll have this part made. Alright, it is all done. I did run into a little bit of snags, so I had to make some changes in the cam, so I ended up having a little bit larger chamfers than I would actually like, but for the most part these are just pockets for tightening up against the mount that mounts it to the column of the machine. So these are just pocket recesses for the cap head screws, and then this is the mount for the air cylinder to go in, and then the linear rail bearings get mounted onto here. All in all, this biggest, as far as largest part I've ever machined on the machine, so it was a little bit tricky. It ended up happening during the setup I had to shift it over just a little bit more when I tried to probe it in place, simply because the probing requires so much x-axis travel, I guess, away from the part. So anyways, the only thing I have left for this particular item, and I'm going to hand tap it, and there is a hole on the side here, and that is for the enclosure door. It's a lever. It gets mounted to here, so when the slide moves, it pulls the door open. So there'll be a mount screw that goes on here, and I'm going to drill and tap that by hand, simply because I know that the tapping head's not going to work because of the physical height of the part. So anyways, that wraps this video up, guys. I really appreciate if you like and subscribe, support the channel. So anyways, we will see you on the next one. Bye.